In this lesson, we'll be talking about sets with Java. So if you recall, this is our big UML diagram. And in previous lessons related to collection data structures, we talked about array list and vectors and stacks and queues and priority queues, right? So this lesson, we will extend that to the notion of sets. A set data structure is one for storing elements that are non-duplicate, right? So it does not store repeated elements, right? So where does set appear in this UML diagram? It is right here, right? The set interface extends the collection interface, right? It doesn't add any new methods or constants or anything, but it does stipulate that this interface and anything that extends it are ones that will have non-duplicate elements. They cannot contain duplicate elements, right? So abstract set is the next one over, which is an abstract class that provides a partial implementation of set. It provides equal and hash code methods, right? But doesn't quite complete the set. And then there are three concrete classes for set that are HashSet, LinkedHashSet, and TreeSet. And we'll go over all three of them in this lesson. So let's see where they appear. So there is HashSet, and then there's LinkedHashSet, and then there's a TreeSet up there. Those are the concrete class implementation. So let's start talking about these. So let's start with HashSet, right? So a HashSet is a concrete class extending abstract set. So we just looked at that, and you have collection, which is the root interface. It goes to set, which is still an interface, and then you go to abstract set, which is an abstract class, and then you go to HashSet, which is a concrete class, provides a full implementation that can be used. Now, HashSet introduces two concepts: capacity, which is how many elements that the set can hold, and then a load factor. Now, load factor measures how full the set is allowed to be before you increase its capacity, right? So by default, the initial capacity, if you don't provide anything, by default, the initial capacity is 16. So it can hold 16 elements, and the default load factor is 0.75. Basically, when you get to 12, when you get past 12, is when the capacity gets doubled from 16 to 32. Now, there are various trade-offs to selecting values for capacity and load factor, to performance and space cost and such, but we will park that discussion till we actually talk about how a HashSet is implemented, how it's actually stored inside, right? So let's first look at the constructors for HashSet. There's a default constructor that you'll see here that will get the default capacity and load factor of 16 and 0.75. You can actually set each of these with a constructor for setting the capacity and constructor for setting the capacity and load factor. Now, there's a constructor here that we want to talk about a bit more. This HashSet is initialized with another collection. But this notation is kind of interesting. You have this collection question mark notation, and this is called a wildcard type, right? So it's a collection question mark is called a wildcard type. And how do you read it? You would read it saying it's a collection of unknown, is how you would want to read it out, right? It's a collection whose element type matches anything, right? Is how you would read that. Now, but this has extends E within the caret. So now this whole thing can be read is really a bounded wildcard, and it can be read as following: that this is a collection whose elements are a subclass of E, right? So it's made up of elements whose type is a subclass of E, is how you would read that. Okay. Now let's move on to the concept of hash code, which is the basis for hash sets. And now a hash set is duplicate free, right? It does not have duplicate elements, right? Objects are added to the hash set, need to implement a method called hash code, right? And so the method hash code maps an object to a number, which is its hash code, right? So if two objects are equal, they should map to the same hash code, and that's how HashSet tells whether that thing might already exist, right? Now, two objects that are not equal may actually map to the same hash code. It is possible, but two objects that map to different hash codes would definitely not be equal. But however, two objects that are not equal may actually map to the same hash code. So you implement hash code to avoid too many of these kind of cases, right? And this is because how it's stored internally, and we'll talk a bit about that. So let's talk about how are these typically implemented. Most Java API classes, like integer and double and all these, they implement this hash code method. Integers basically map map to their int value for the hash code function. So their hash code is essentially the integer value. Characters will look at their Unicode or ASCII encoding to implement hash code. For strings, there is this summation that we do. So based on the character position, you calculate a number based on this formula to get its hash code, right? So then basically how we implement HashSet is the HashSet has a bunch of buckets, and when we put something in there, you calculate its hash code, and you go to that bucket and you put it in there, right? And if there's something already in that bucket, then you create a list of things that are hanging off of that bucket, right? So, and that's why this capacity and load factor becomes interesting, because the smaller the capacity, the more things will be hanging off of each bucket, and your search time would be increased, right? The bigger the capacity, it might be more nicely spread out, but then you're using, might be using kind of more memory. So that's kind of the trade-off, and we'll get more into these details as we go on, right? And as we think about performance of each of these things. Okay, so let's move on. Let's actually look at some code and how this stuff works. So here's a very simple example of us using HashSet. We have created a little main program with the main class, and we've created a HashSet. Now, set here is the interface, and we can use that as a type because we're allowed to do that. The generic type is string, and we create a HashSet of strings, and then we go ahead and add a bunch of stuff to it, right? Because add is provided to us as part of the whole collection infrastructure. So we've added London, Paris, New York, San Francisco, Beijing, and New York again, right? And then we print this set and we show it, and interesting things will happen. So let's take a look at it. Let's actually take this and run it. We'll fire up IntelliJ and see what happens. Okay, so I've basically copied that code here, and some warnings I'm getting interesting, but I won't look at that for now, right? So then I have, we have added these things. Let's show that, and we'll see what prints. We're printing it, and then we have a for each loop for printing it by just calling uppercase, just doing something interesting with the for each loop. So one thing you'll notice is that things are not kept in the order that they were added. London was added first, but it appears somewhere here. Paris was added, then appears last, and then New York was added in, and so it is not, and Beijing was added last, but it's appears second. So it is not, and this is because of the hash code. When these things are added, they are you got a hash code and you put it in a bucket that maps to that code. All right. So, and the other thing to notice here is that New York was added twice, but it only appears once. And that's because of the nature of a set where you don't allow duplicate entries. And to some extent, hash code is used to tell whether you have a duplicate entry. There, you add, it mapped to the same bucket. You go to the bucket and see if New York's already there. If it's there, then you won't really add it. Okay, so that's our first little foray into using sets. Okay, so that's what I talk about here. So then basically reiterating that elements are not stored in the order inserted. They are, hash sets are unordered. You cannot depend on the order. New York only appears once, even though it's added twice. And because set extends collections and which extends iterable, if you remember from previous lessons, we can use this for each loop in this nice convenient way, right? So and since a set is an instance of collection, all the methods from collections are available to us to use, even though here we've just used add. So let's just see what other things are available to us here in the slightly longer example. I have done the add here, right? And I can use size. I can remove something from it. So in here, I've added 5 things, and they appear here. The size is 5. Then I go ahead and remove London. It removes London. Then I create a second set, right, and add a bunch of things to it and print it, right? And then I check whether the second set contains type A, which it does not, so it'll return false. So this is contains is something available to us. Add all is kind of a union, so you take set 1, you add all to set 2, and then you get a union of these things. Notice that Paris appears in both, but it only appears once here, so it's a union, but it still does not keep duplicates. Remove all basically removes everything that is in set 2 from set 1. So set 2 had Shanghai, Paris, London. So basically it'll get rid of the Shanghai, Paris, and London from it, and it'll become much smaller. And then retain all is basically an intersection of them, and there is no more intersection, so it's empty. We can really quickly try this out, and this might form as a basis for you to experiment with this, so feel free to go ahead and do that. We pasted it here, all good, and we'll run it, and give this as the expected output that is mentioned in the comments. Okay, let's move right along. So now let's get to the very next thing we have, which is a linked hash set. A linked hash set extends HashSet with a linked list implementation that supports ordering, right? So HashSet, did not have ordering. You could not depend on an order. Now here you have a notion of ordering is added. Linked list elements are stored and retrieved in the order that they were inserted, right? Again, 4 constructors are supported that you are very used to. I will not go over it again, right? And now let's look at the earlier example, the very short example that we had earlier, and see how it's different. So here now I'm using linked hash set. So let's try that out and see how that is different. We'll take that. We'll get rid of this. And override this. So now this is a very simple implementation. You have linked hash set, and see what it does. I am printing it, and then I'm printing a lowercase version of it, just a slightly different. So I'm printing what I was added, and a lowercase version of it because we can use the for each. What is the difference? The difference is it is put in the order that I added it. It still doesn't have duplicates, right? So okay. let's go back. So as I said, so New York is only stored once because it is still a set and maintains the order, right? Now the last one we will look at is something called a tree set, right? And where does the tree set appear? A tree set appears right here. So the set is extended by another interface called sorted set. Then you have a navigable set, and then that's where TreeSet is an implementation of. So a sorted set extends set and ensures that elements are kept sorted, right? It adds a few methods, first, last, head set, and tail set, which gets you a subset up to a certain element. Then there's navigable set, which is extend sorted set to provide navigation methods such as lower, floor, ceiling, higher, and they return elements that are less than or equal to, greater than or equal to, and such, to the of the element that is provided, the element E that's provided, and poll first and poll last remove and return the first and last element. So it's added these things. Then a tree set is basically an implementation of all of those things and is a concrete class, right? You can add elements to a tree set and they can be compared to each other and things like that, right? Now recall that there are two ways where things can, now the fact that it's sorted, that must mean that there must be a notion of comparing elements. Without comparing elements, you cannot really sort them. So there were two ways, remember, that we could compare elements is if an object implements comparable or there's an implementation of comparators. If you don't remember what those are, review those lessons, right? So TreeSet provides constructors for both ways of doing that. So now let's as the last thing, let's take a look at an extended example of using TreeSet. Now here we have built a hash set and added a bunch of things to it as before. Then we're using this set to build a tree set. Now, how is this different? Now, this different is now it still has the same number of elements, but now they're kept in a sorted order. Now, since these are strings, the comparable that's used is comparing strings alphanumerically. So that's why they are kept in an increasing alphanumeric order, right? And you can use elements first to get the first element, the last to get the last element. You can get a head set, which means give me a subset of this going up to but not including New York. So it gives you Beijing and London. And then you can get a tail set saying, give me elements in the end from New York, including New York, all the way to the end, so it gives us New York, Paris, and San Francisco. And then it says, so you take a hypothetical string P, and you give me something that is less than or equal to. So less than P is New York, less than or equal to is Paris, and floor and ceiling, first pole, last. These are all kind of work in kind of the same way. And since we've called pole first and pole last, those elements are removed when you do that, and that's why you get the middle three at the end. And we can very quickly take this and run it just to show you that this is not made up, and this actually is something that works. So feel here, sorry, I may not have. Okay. This is the whole thing, and if we run it, we should pretty much get what we are expecting from the comments. All right. So final concepts here. We should compare how lists are different from sets. So elements of a list can be access with an index. So you can say, give me the fifth element, and there's no such concept for sets. Sets are unordered, right? Hence, they do not support indexing, right? But you do have a for each loop because of the iterator implementation to traverse the elements of a set. Sets are more efficient than lists for checking if an element is in the collection. The reason for that is because of the hash code. It lets you quickly get to a bucket and look for something in a bucket. All right, so this has been a lesson on sets.